Can you see this strip?
No, your screen is blank now.
Oh,
Your screen is blank now.
let me try it again. Okay.
You
Can you?
can see it now.
Oh, okay. Can you see this
Yes.
strip? Okay. So now, watch the P wave in this strip now. You see that it is also negative. P wave, it is normally negative in AVR. So when you see your P wave negative in your patient's AVR, don't say, oh, something is wrong with the patient or anything. No. Those are some precautions that we have to take. Okay, that is why inter just performing the test is not enough. You have to really know how to interpret it. And then it is also biphasic in V1. That biphasic wave that I showed you that time in V1, it is biphasic. But this one, our V1, it is not clear very well. So that let's just ignore that. I've also tried checking out some of these leads, but it is not really obvious in them. But if you see a biphasic lead in your V1, nothing is wrong with your patient. Okay, so V1 P wave is negative in AVR, and by I think it's showing here. Can you see this biphasic? It's not so prominent, but then you can see what I'm trying to say. Equal negative, equal positive. Can you see it? You guys are not seeing it.
Yes, we
You
can.
can see it. You can
You can see it. Okay. So for those that are not on the call, let me send this image to the group now, so they are not going to miss out on anything. Where is it? So those that are not here, we're referring to V1 P wave being biphasic in V1. So that is that equal positive, equal negative. Because see, well, in ECG strip there can be something that will look like, let me show you, that will look like W and that will look like M. Eh? That one is another abnormality, and like it's like a really big one. But may we not have it though, by God's grace. It's going to, but it's even for our QRS. On the QRS, it's going to look like W and then M. Let me, so I sent the image to the group. So that's just what it's going to look like. So what I'm now, why am I saying this? So that you not go and interpret the biphasic on the V1 to go and be that something I'm talking about. Please. It is not, all those one is a hypertrophy, left ventricular hypertrophy, all those things. So your P wave, it is normally biphasic in V1, and in AVR it is negative. Do you understand? That's, please, I'm taking my time to take it slow. Do you understand what I'm trying to say?
Yes, mom.
All right, thank you. Let's continue.
I did not get what you said last.
Oh, okay. So I was saying that P wave, it is negative in AVR, right? I already explained that before, but it is biphasic in V1. And then I showed you that image of P wave being an example of it being biphasic in V1. Did you see it up to that place? I can't really see the name of person that.
Yes, I did.
So now that W and M, I'm telling you that there's also an abnormality, right? Where it can come out as where you're on your strip, you can see something like W or M, but it is usually on the QRS. Why am I saying this is that so that you will not go and interpret that biphasic that is on V1 to go and be that W and M, because that those things are actually right ventricular hypertrophy. And since I already told you that it is P wave is biphasic in V1, so don't go and that biphasic that we saw now, it's almost looking like WM kind of sha. I'm just telling you to be careful so you not go and interpret it as another thing. And you also have to know that biphasic is equal negative equal positive. So check out if it's equal, then you know that it is a biphasic. Okay, so just be careful when interpreting. Do you understand me?
Yes,
Yeah.
mom.
Okay, so let's continue because we have to finish this thing today. So then the QRS complex now. I said the QRS complex represents ventricular depolarization, like I told you. Time it takes for the impulse to travel through the bundle branches to the Purkinje fiber. I've explained all this one in the first week. The Q wave when present. The Q wave is the first negative deflection in the QRS complex. I'll show you the image now. R wave is the first positive. Then the S wave is the second negative deflection. Let me show you what we are trying to say. Next one. Shey you see now, this thing, this Q wave is not prominent because Q wave is not usually prominent. It's just one small thing because no, even for Q wave itself, it's not supposed to be more than one small box. For your Q wave gangan, the height the height and the is it length? No, is it length abi the wideness jare? Both height and wideness not supposed to be more than one small box. So please take note. So Q wave is just it's a very small thing, but it is there. You will know that it is there. You'll be seeing it there as a physiologist. You have to see it. But what I'm just trying to say is that it's really small. Like this strip now. Can you see the Q here that is here? There's a Q here. Can you see that negative deflection?
Yes.
Can you guys see? So that is the first negative deflection in the QRS complex. And then the R wave. R is usually our tallest wave. R can be as tall as honestly can be as tall as 10 small boxes, 15 small boxes. Okay, so it is really tall. And there's some calculation that we are going to do. You can calculate R in V1 plus V5 is no more than 35 small boxes. See, we are going to get there. Don't worry, don't be scared. But what I'm just
I
trying.
don't understand. Oh.
No, don't worry, you don't have to understand now. Those ones is interpretation gangan. When we start interpretation, this one that we are still doing, I'm just introducing you to what it's going to be like, okay? When we get there, we're going to be doing some small calculations and then some grammar and everything. But don't worry, I'm going to try my best to break it down as little and as easy for you. What I'm just trying to tell you here is that R is the positive one in the QRS complex. And S, you can see the S again. S is that one that is going down. So it's just like Q coming down, then R going up, S coming down. So that's just our QRS complex. Let me show you another image. um it's not so clear. Sorry, it's not really clear in these images, but then you can see it that there's some waves actually they don't have Q. It's going to be like it's not going to be there. That doesn't mean something is wrong with your patient too. And because I said that your R is the longest doesn't mean that you should now interpret. See now, let us check this V2 now. This V2 and V1. You see that the S wave is long. So don't go and interpret that S wave as R wave because I told you that R is to be long. Don't kill your patient. R wave is the positive one and S and Q they are always negative. S can never be positive. Dat one is not even abnormality anything, e can never ni. So no matter how long e wants to be, it is always the S wave. R is always the positive one. So that's just what I'm trying to point out in the QRS just for you to be able
So,
to identify.
sorry, ma. Sorry,
Okay.
ma. In this image you just showed us, that means the R wave is one taking like 5 boxes, then the S wave in the V2, not this one, the one before this one.
Oh, okay.
Yes,
Yes,
this one.
yes,
No, the
yes.
other one, not this one. Not this one, the other one.
This
For
one.
V2, yes,
Okay.
For V2, yes. The is the R wave that is now up to 5 boxes, and the
Yes.
S wave is the one down, Abby.
Yes, yes, it's the one down. So S
Okay.
wave will always be down. Always. It is a negative deflection. Always be negative. While R wave always positive. Q wave always negative. So let's move on to the duration. So the duration of QRS is 0.06 to 0.10. Let us go to our calculator. So it's not going to look like magic or anything. So 0.0 is like we did earlier, divided by 0.04, 1.5. 0.10 divided by 0.04, 2.5. So your QRS is from 1.5 to 2.5 small boxes. Q P wave was from 1.5 to 3 abi. Your QRS 1.5 to 2.5. You don't say because why is P wave now going to be longer than QRS? QRS is not comprising of three things. It's not supposed to be wider. Rárá, this is the standard. Okay, it is 1.5 to 2.5 small boxes, and then 0.6 to 0.10 second. Shey you see this one now, where you are going to count it from the beginning of Q to this J point. There's now another thing we call, okay, we are even going to get there, it's inside the note. So this one that I'm touching, this U, from the beginning of this Q, because that is QRS, and then to where this S ends, so that's where you are going to count. It has to be 1.5 to 2.5. It is already, if it's already getting longer than that, there's actually a problem. Okay, but QRS, the duration, like this, like the wideness is not usually a problem. Like it's just the height, and that height we have to calculate some things. We have to compare like two or more leads and then other things. Yeah, but we're going to do that in the interpretation. Just for you to know that the duration for QRS complex is 0.06 to 0.10. It can be confusing, honestly, because now we already said that P wave 0.06 to 0.12. QRS is now 0.06 to 0.10. Just don't let it scatter. Read again and read. That's why I'm making sure that we do our weekly tests so that you will not forget. So let me continue. Do you understand up to what I've said now? Do you understand? If you don't understand, let me know, please.
For
I
for
don't
this
really
image,
understand it much. You don't understand the graph.
Yes.
Freedom, you were saying.
for the image you just showed us, the QRS complex is just taking one box.
Yes.
It's not even up to 1.5. Yes.
Well,
Just everything is just in one box.
actually, it's just one box, but that does not mean that your patient has an abnormality. Please, do you get what I'm saying? The fact that it's taking one box, but that's why I was saying that QRS complex doesn't really have any abnormality when it comes to the wideness. Okay, it is the height that is usually a problem, because there are some things that the R will be very very long, and those are hypertrophy, right ventricular, left ventricular hypertrophy. We'll get to that later. Okay, and since this one is not taking more than one box, doesn't still make us believe that something is wrong with our patients, because normally in the interpretation there are so many factors that contribute to whether you really have to confirm that that patient is having that abnormality, and then this is just one of it. Okay, and this that is not having 1.5 small box, 1.5 small box, is not enough to tell us that, let's say it was half now, or maybe it was so tiny that we are not even seeing the distinction between the like the R wave is not is not even wide at all, like there's no space in between there. We can say, okay, let's check that place, maybe something is wrong with that place. But usually for QRS, the duration does not really have an effect on the result of the patient. Let's say for the P wave now, the P wave is too wide, yes, something is wrong with the patient. If it's too long, something is wrong. Or if it is inverted in wave that is, like, I mean inverted in case of negative, and the is it's not in AVL, because I already told that it is normally negative in AVL. That one we can say something is wrong. There are a lot of abnormalities that could be wrong with the person. So now I told you earlier that there are 13 things that we have to analyze in an ECG strip to confirm that patient this thing. As you go on, you learn to analyze them faster, that you don't even check some things and you just confirm the result. So these things are the little variations that are in ECG strip. This one can just be, if it can be as maybe even from a result of maybe patient shaked a bit, or maybe the calibration, or even something can happen, or maybe the wires were not placed straight, or maybe the gel was not enough. So this is not still enough to tell us that something is actually wrong with our patient. Do you guys get what I'm trying to say? So from
Yes, ma'am.
experience, and as you move on, you get to know the things that really contribute to it, because these things that we're doing now, I have to teach you, because if I don't teach you, you're not going to understand the interpretation. But as we go on and move to the interpretation, you learn the things that are really say, that you can really say, okay, this patient has left ventricular hypertrophy. This patient has tachycardia, bradycardia, has this, has that, has ST elevation, myocardial infarction, myocardial ischemia. Those ones are the really tough abnormalities that you cannot ignore. But this one is just one of the little things that occur. Do you get what I'm trying to say? So the person that said she did not understand the graph, do you understand now, or I should take it again? You guys are not hearing me.
We are hearing you.
Yes, ma'am, we understand. I understand it now, ma.
Oh, okay, thank you. So let's move to, I want to show you something. There's something we call J point in an ECG strip. Mm, Those I was referring to that time. So for those that are not here, let me just download this image and send it to the group. So this is what we call a J point. This is a J point. J point is the time, it is where your QRS complex stops and your T wave starts. It's just that chuku side. Let me, okay, this is not where I'm sending it. Let me send it to the group so people can also, so that's just your J point. And there's something we even call, your J point can be elevated. You see all these flat these things, all these segments, intervals, we are going to get there though. What can actually happen to them is either elevation or depression. Those ones don't have duration like okay, they do actually. But what I'm trying to point out is that they can either be elevated, okay, or depressed, just like the ST segment and the, but we're going to get there. I'm just trying to tell you that there's something in the ECG strip that we call the J point, and this is that point from where your T wave starts to where your QRS stops. Because it's our P, then QRS. The S is not, there's no negative deflection. Another thing that can also happen is that sometimes you are not even going to see the S wave there, and that doesn't still mean that something is wrong with your patient. So these are just the little things that we have to note as physiologists. Okay, that's why I'm taking my time to go back and forth and tell you these things as I remember them. So you might not even see some waves that will have S wave, and there are some that will have it. Okay, it doesn't still mean that something is wrong with your patient. So now there's this J point. Let's just continue. I was only trying to show you the J point. I feel like I should just open this PDF from here. Going to that, where is the, oh, check here. Do. Let's just continue. So we're going to move into our T wave now. So I've done P, Q, R, S, T. Oh, sorry. I want to do T now. So now this T wave is usually following the same deflection pattern as the P wave. I told you. Let's go back to that P wave. See now, This is P wave and then this is T wave. I told you that it is usually broader than the P wave because the ventricles um take longer time to repolarize. They take longer time to be filled with blood. I told you in the first class, if you remember, that is why the T wave, and you can see it now, it is broader than the P wave. So that's just one point. Your T wave is usually broader than your P wave. Okay, so don't go and mistake your T wave for your P wave. So once you can count P, then the QRS, the next one is the T, not your P. QRS, the next one is your T o, not your P o, please. So that is just by the way. And then okay, tall peaked T waves indicates myocardial injury. This one I just imputed it, but then we are going to do it in our interpretation. But another thing you need to know is that P wave, P wave doesn't really have any duration like that, because what we used to deal with in our P wave is usually the tallness, and the criteria for the tallness in the P wave is that it must not be longer than half of the preceding QRS complex. Òyìnbó yẹn pọ̀.
Please, can you come again?
Yes, I'm going to come again. After QRS, we have T. Your T must not be longer than half of the QRS that is coming before it. Freedom is taller than me. Is QRS complex. Me, I am T wave. And it's standing before me, standing at my back. Me, I must not be taller than half of freedom. Your T wave must not be taller than half of your QRS. All these things that you are going to use if you want to count the boxes of your QRS, so that you know how tall is it and how tall it is, and you divide it to know the half. You can do that. But me, I don't count again. When I was just learning, I'll be counting boxes, but then I don't really do that again. So your T wave must not be taller than half of the preceding the one that is coming before it. It must not be taller than half of the preceding QRS. Do you understand that grammar there now?
Yes, ma. But wait, there are some strips. There are some strips that is showing that is some of the T wave is taller than the QRSO, like this V2.
Then there's a
You know the S is
mm,
is on the negative side. So
okay.
this
I can
this
see what you're saying. I can see what you're saying. This strip now, something is wrong with the patient. There's T wave elevation here. So there's something wrong with, I told you that tall peak P waves means myocardial injury. So there's actually something wrong with the myocardium of that person. So I'm not showing you these waves to tell you that they are normal waves. These strips, the only one that I can say is normal here is just this straight one that I gave you here, okay? Because this one is just one thing, and then it was just an illustration. But I'm coming. Let us look for T wave elevation here, so you can really see it very well. Because it should never be longer than the preceding. Now let's check this V5. Do you see this V5 now? I see that it's already do you see this V5? This one. Come. Sorry. This one. Can you guys see what I'm saying? It is longer than it. Even some is the same height. Like this one now. This first one is the same height. This second one is longer, and then this V6 is what? The same height. Can you see what I'm saying? Can you guys hear me? Yeah.
yes, ma.
Oh, okay. Please.
Yes, ma.
So that's just what I mean by the T wave elevation. But we're not yet doing interpretation. We're going to get to that subsequent, not next week, not next 2 weeks, maybe next 3 weeks, because we have to do like some things that we have never heard before first, that we have to interpret first. So that's just what can happen to our T wave, right? And then I saw something now that that was looking like, okay, don't worry, let's just continue. Don't let me scatter your head again. So let us go back. Now I was asking you if I mentioned something that had to do with U wave that time, and you said I did not. So your U wave, it is also part of your strip, but it is not usually seen. Before you see U wave, it's very very rare, because it's almost like a straight line, but just slight. It's not up to half of a small box. It's not up to quarter. It's so flat. Okay, but when it is prominent, it can actually indicate these three things: hypercalcemia, hypokalemia, or digoxin toxicity. All this one is grammar, don't worry. When we start it, I'm going to show you all these strips, and then what your patient is having if your P wave is what, sorry, excuse me. What do you want to go and buy? What do you want to go and buy? Oh yeah, now where is the cash? Wàhálà mo fi sí o. Where? This wire don break. Oh, what's one? Wire, this one wire. Tell me, if everybody might want to charge. Tell me, how much did I give her? 500. Oh, they already buy this thing though. Wow, I don't understand. Come now. Anima, you see that I'm doing something, no, be fast. It's 500 that remain now. We don't see pepper 500. Sorry, I meant to attend to something. So as I was saying that your P wave, sorry, your U wave is not usually seen, but it's because it's usually flat. But let's check for images that have U wave in them, and then we'll check for the ones that have U wave prominence. U wave ECG. Okay. This is an example of, okay, let me just use this one. Can you see that U wave that the thing is showing? Let me download the image for those that are not in class. Can you guys see the U waves?
Yes, yes, ma'am.
This one is
Yes, ma'am.
even, because this one is even prominent. On the normal ECG, I don't think I've come across this U wave more than maybe 10 up to 20 times since I've been doing ECG. But then, because it's not usually prominent, it's just one small flat wave. But when it is now prominent, there's a problem, and it can be more when you have a lot of calcium or you have low potassium. Those ones has to do with ions in our body. So ECG is really like, that's why ECG is a very very important test. I told you, you can detect if someone has hypertension. You can even detect if you have plenty calciums in your body, low calcium, higher potassiums, or all those things. But we're going to go into that. This is going to be like the last part of our interpretation, because we are going to be picking the waves one by one. So now let's move to the intervals. PR interval. Let me show you. I sent you guys an image one time, but let me send it again, because of those that are not in the class. I don't really like this one. There's another one that, okay. Let me send this one. Message me. And for those that are not in class, for the U wave, this was the image that we used for the U wave. It was not a photo, okay. How did I now get it? Let me just screenshot it. So now we have our PR interval. Our PR interval is from where the P wave is starting. This ones can be actually confusing. All this where it is starting to where it is stopping when it comes to intervals and segments. And honestly, I don't really know any easier way for you to memorize. Just for you to, you can actually imagine the strip in your head. Because that's what I do. I just imagine the whole picture in my head and then use it to answer any question that I see under it. Sha. But then your PR interval is from where your P wave is starting to where your Q is starting from. Your QRS complex is starting from rather. So it's your PR interval is from where your P wave is starting to where your QRS is starting. Let's go back to our PDF so I can show you the things that you need to know under the PR interval. Now, the PR interval represents the time it takes for an impulse to travel from the atria through the AV node and bundle of ears. We already explained all of that in our first class. The PR interval is measured from beginning of P wave to beginning of QRS. I already told you that. And the duration of our PR interval, it is 0.12 to 0.20 seconds. That is how many? 3 to 5 small boxes. Okay. I'm sure you already understand the concept of this duration. I just divided none 0.12 to 0.20 seconds, and that is 3 to 5 small boxes. So our PR interval is usually from 3 small boxes to 5 small boxes. It should not be longer than that. 3 small boxes, 5 small boxes, 3 small boxes to 5 small boxes. Usually, the problem is usually when it is longer, not really when it is shorter. It's when it is longer ni wahala wa, because it is going slow. The longer it goes, the slower it contracts. Okay, so it's from 0.12 to 0.20, 3 to 5 small boxes. Now let's move to our PR segment. The PR segment on the ECG represents the period between the end of the P wave and the beginning of our QRS complex. The interval was the beginning of P wave to beginning of QRS, but the segment end of the P wave to the beginning of the QRS complex. You can check this strip because I don't want to leave this thing again. You can check that email that I sent to you to the group now. And then it starts at the end of the P wave, which marks the completion of atrial depolarization, because P wave represents atrial depolarization. And if something is starting from the end of the atrial depolarization, end of the P wave shows that the completion, the atrial has depolarized, that it has been, the atrial depolarization has been completed. And the PR segment is usually from 3 to 5 small boxes too on an ECG. Hold that one. PR interval, PR segment, 3 to 5 small boxes. Now let's move to our QT interval. For this QT interval, there's some things that you need to know here, which is that the QT interval, okay. Normally, the QT interval actually varies with the heart rate because it gets shorter as the heart rate increases. The QT interval, it gets shorter as the heart rate increases. This is just an MCQ question. It gets shorter as the heart rate increases. It gets shorter as the heart rate increases. Now, so it extends from the beginning of the QRS complex to the end of the T wave. Let's go and search for an image because I don't want us to leave this space. Waves on an ECG. This is the image. So now the QT interval extends from the beginning of the QRS complex to the end of the T wave. It will extend from the beginning of the QRS complex to the end of the T wave. Beginning of QRS to the end of the T wave. So now, and if average is out rate, I already told you that. They said a normal QT interval for men. This QT interval, it varies with the gender, and this is the only one that actually varies with the gender out of everything. So the QT interval varies from the gender. For men, it is typically from 9 to 11.5 small boxes. For women, 8.75 to 11 see, leave all those 0.75. Dat 8.75 you can leave it at 9, and den the 11.25 you can just make it 9 to 11 small boxes, so dat you no gats be looking for 0.25 again on your strip. Okay, so 9 to 11.5, dat one can still be estimated, 11.5 for men and den 9 to 11 for women. In hypercalcemia, hypercalcemia means that the CaLC that is there is calcium. Hyper, you have so many calcium ions in your body. Hypercalcemia means that your QT interval is short. Hypo means when something is little or few, or it's not much. That's hypocal. The calcium ions in your body is low, low, and that is QT elongation. So the QT and the quantity of calcium ions, they are like they are inversely proportional. Just like if you have plenty calcium in your body, the QT is going to be what? It's going to be short. If you have low calcium in your body, the QT is going to be long. I'm just trying to input this so that you know, be able to familiar with this abnormality terms. These are the easiest one that you can understand now. The rest you have to know them through the strip, and then I'm going to be explaining them in subsequent classes when we start our interpretation. But what you need to know now is that for men it is 9 to 11.5 small boxes, and for women it is 8 point sorry, you can just use 9 to 11 small boxes, because I don't want you to now go and be looking for 7.5 and then 2.5 on the strip. That's going to be confusing. Now there's something that we call
Sorry, I'm confused. You said low calcium is hypokalemia or something like that. Is
hypocalcemia.
it calcium or potassium? Or
It is calcium. Okay, sorry. Let me check. It's calcium. Hypokalemia is potassium. Let me um spell the difference for you. Hypokalemia is the one that has to do with potassium. Can you see?
okay, thank you.
Hypocalcemia
Yeah,
is the one that has to do with calcium. Just for the people that are not on this call. So that's just the difference between the both of them. So let us go back to our explanation. So we're talking about QTC. QTC means corrected QT interval. That C there means corrected. QTC means corrected QT interval. QTC, corrected QT interval. You know, I told you that QT interval dey vary with the heart rate. As the heart rate get faster, the QT get shorter. Now dey now had to employ this QTC to correct that changes in the heart rate. So QTC is used regardless of the heart rate. So that is why it is the correct one, because regardless of the heart rate, once you get it, that is the should I say the aggregate QT or the average QT interval sha. The QT, I told you, the QT interval gangan, it varies according to heart rate. They now had to develop the QTC, which is the corrected one. That one will work regardless of what? Of the heart rate. How do we? And the so for QTC, normal ranges are 9 to 11 small boxes for men, and then 9 to 11.5 small boxes for women. I must have made a mistake here. It is the opposite. I'm really sorry. It is 9 to 11.5 for men, and then 9 to 11 for women, as I said in the QT interval. But then the advantage of this QTC is that it allows us to compare QT values across patients, no matter their heart rate. The formula that we use to calculate this QTC is that it is QT interval, the number of small boxes that you get in your QT interval, that range between 9 to 11, whatever you get in your QT interval, over square root of RR. R to R is that RR. R to R means that the boxes between one R and the second R. Let me show you what R to R means. Okay, it's going to be in this thing. R to R is just the space between two R interval. When we get to rate, we are going to do that one. You see this R and this R, whatever is between them, this R and this R, this R and this R. And another thing that you now need to note is that this thing can only work for a regular reading. We will get to regular, irregular, regular, irregular reading next week. And I'm going to come back here when we get to QT interval in the interpretation. But just know that there's something called QTC and there's something called QT interval. Because I'm trying my best not to pack so much information that you'll not be able to get all what I'm going to be saying in subsequent classes, because we have not even gotten the bulk of the work. From next week now, we will start the real interpretation. Okay, so this is just like an introduction to everything we are going to be interpreting. But I already told you what R to R is now. What is between one R to one R? R, 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 R. What is between them? How many boxes? This is an R to R now. This R, you're going to count how many. This one is like 1, then this one is 5, that's 6, then 5, 11, then another 5, that's like 16. And then you're going to find the square root. You divide both of them. So that's that formula, and that formula is called the Bazzet's formula for calculating the QTC. But most time, this one is just for study sake only. Most of the time, when something is wrong with your QT, you actually know, because you see that the small box itself is not different from the one for the QT. So you will really know. All you need to know is 9 to 11, 9 to 11.5 for the genders, okay? Because I don't want you to start getting worked up on then one formula, please. Because I'm trying to be as realistic and as possible for the things that actually helped me. Because it's not everything that you learn that you're actually going to apply in the interpretation. But these are the things that are important. And it's going to come out in your test. So because I said that kiniko, don't think it's not going to come out in your test. It's going to come out. So, I don't even know that I mentioned J point here. So our J point and then our ST segment. I already explained what J point is. Now let's just move to our ST segment. ST segment is part of the ventricular repolarization. I was showing you something there. So we'll check what our ST segment means. So ST segment is from that J point to where your T wave is starting from. I'm sure everybody can now recognize the J point now. Do you know are you
Yes,
seeing
ma'am.
the J point here? Okay, so
Yes, ma'am. Yes, ma'am.
from that J point to the beginning of our T wave, that's our J point. That is our ST segment. ST segment from the J point to the beginning of the T wave. Sorry, I'm really tired. So, and then extends from the S wave. S wave J point is still that same corner. So to the beginning of the T wave, and then any change in ST segment indicate myocardial damage. Yes, myocardial ischemia, myocardial infarction, gbogbo myocardial kinikan kinikan is ST segment, and it's really those things are actually critical abnormalities, and that is the last thing we are going to be doing in the class when we get to that place. Yeah. So please, from everything we have done today, do you understand everything that we've seen this morning? Do you understand?
Bẹ́ẹ̀ni mà.
Good evening.
Bẹ́ẹ̀ni mà.
Oh, okay.
Yes,
Then
ma'am. Yes, ma'am.
so the amplitudes. Okay, yeah. But I don't know. Later, I thought of not. It's all
Please, I have a question.
okay. Okay. Tell me.
The first picture you sent on J point, the diagram is different from this ST segment, the one you used to show ST segment.
Coming. Let me look for the one for J point too.
Like in the first diagram, they didn't show that S
Yeah,
complex.
I'm coming.
Yes.
Let me go back to the image. I explained that time that some of your QRS doesn't have S wave. So let's use this image. Can you see now?
Yes, I can see.
Everything now. Do you understand now?
Yes, I understand. Thank you.
So this amplitude is just how long. You see how long? I be the height, sha. Everything we have been saying since has been like the duration, right? Now, this SC segment, this amplitude, I don't want us to do it now because you are going to get confused. When we get to our interpretation, we are going to treat everything because we have like, I'm coming, let me show you something. I don't know if I sent you the slides, but then I really want to use, so we're going to check through it. Those are the elevation. See all the things that we are still going to do. I'm going to pick everything one by one, one by one. These are the bundle branch blocks. We're going to pick it one by one. The Wolf Parkinson White syndrome. We're going to treat all the art blocks, first degree, second degree, third degree. That's for PR interval. See, these are the P pulmonale. This is the biphasic. This is the P mitral. We're going to start with the P wave, and then we're going to do our axis deviation. These are the cardiac axis, and then we're going to do all the rhythms, every type of rhythm that you can see. After all this one, Kilato machine, we're going to do our rate. We haven't started with rate. These are the things that I said that to calculate an ECG, we have to know rate, rhythm, axis, then P wave, PR interval, QRS, ST, QT interval, T wave, U wave, and then other. Eh? I'm almost done. What happened? I wanted to come and see one girl and tell us the price you will give the girl. They come. I'm coming. Okay, just 2,000. So sorry. So these are the things that we have to do. So now, so far we have done how to everything about our waves, the introduction to ECG, our calibration. I've also done the basics of the heart, and then from next week we're going to be starting properly. We're going to be going into waves, the interpretation of the everything, interpretation of the waves, interpretation of the strip. And like I said, I'm going to get some strips for you. I'm going to go to the ECG word and try to, get some strips for you to use. And another thing I need to know, I need to tell you is that if there's any way at all that you want to go and do your internship, right? For those that are in last who come, I'm going to arrange something for you, don't worry. After the whole class. One thing I want you to know is that, okay, by the end of this class, trust me, you'll be able to interpret ECG very well. And that is really going to help you. Because if you are going to where they are going to where your IT place or your COS or anything, They are not really going to teach you these things in depthly, because honestly, most of what they are going to be doing is just to be um fixing, delete, fixing, and then it's just the physiologist that's going to be checking. Oh, this one is good. Oh, yeah, do another one. Can you sure you get what I want to tell you? It is not even part of the class or anything. But please, wherever you find yourself, make sure you're of good character. It's not enough to know something. Honestly, these technical skills are not enough. You really have to have your own soft skills, very well. Your communication skills, your manners, the way you dress, the way you carry yourself, the way you attend to patients, the way you address patients, how patients feel comfortable with you, the way you respect each other, the way you do good. Know what, pay attention to what they are teaching you, because honestly, you don't, these things have like they are what have really helped me in where I intend. Up till today, I can walk into that ECG ward anytime, any day, refer people there. It's just a matter of talking to the man, and then it's going to, because when I was there, even me, I know that I saved them in that place. So you just have to be really, really committed and dedicated to what you are doing. Don't let ego or anything disturb you, or don't. I've been looking. I told you guys. I don't know if I told you. I've been looking for an internship, and then it was just last week I got it. And how did I get it? I had to go back to that physiologist because they didn't have. I didn't even know they had that last safe. Because the one, there's a hospital at our place, BT, and then BT is a very private hospital. It's so hard to enter. You have to have like really strong connections. I had to start checking out other hospitals, working in the sun and everything. And I didn't even get any of them. I just went back to that man, and then I told him what happened. Because I was not even expecting to provide a solution. I just wanted to rant and then let everything out. And in a matter of hours, he just connected me with the physiologist at the echocardiography ward. And then the man is a walking Holter ECG, can interpret any Holter, and that's the only one that we have in Lasuth. And then it was so easy. They made the man even like address me and everything. He made the one that wanted to teach me, was like, okay, because of you now, I'm going to accept her and see how serious she is and everything. And last week, I was rounding the waist. The man said I should go and look for his number elsewhere. I should be messaging him every day. I messaged him Monday to Friday. So till Friday, I was able to get a chance with him, because OTA is not something that you do every day. It's 24 hours, and they're analyzing. When I saw the old computers, and then they printed about 10 pages of the results, and I know that this one is not sherry, and then they explained this really well. And then what am I trying to say is that you really have to be of good character. Go into a place and live there better than the way you met it. Leave the people on a good note. Let them know, that girl, she's good. Because honestly, you don't know. All you need is a recommendation, a connection, a this, a that, a word for you, and all of that. Okay, this is not part of what we are doing. But subsequently, I'm going to give you some tips or things that have really worked for me over time. And I'm going to be as realistic as possible, because there's no really point in trying to sugarcoat anything for you. Okay, wherever you find yourself, be of good character, respect them, let them know, okay, you are good, you are serious, you are ready to learn. Because trust me, there are other people that want to learn this thing, and then they were not allowed. They have to pay for courses to learn this thing. So please just be of good character. And then in the absence of, I wanted to check what we're having next week. This is even our third week like this. Okay, we're going to be doing wait and reading next week. Okay, no problem. So, in conclusion, I hope I've been able to convince you and not to confuse you that we have come to the end of today's class. So, I'm going to see you next week, and your
Thank you,
test
man.
expected. You're welcome. Bye bye. Take care.
Bye bye, man.
Bye.